They weren't built for war or for passengers. They were built to push the impossible. For over 70 years, NASA's X-planes have tested the edges of speed, altitude and control, breaking records that shaped everything we know about flight. From Chuck Yeager's X-1 breaking the sound barrier to today's X-59, designed to fly faster than sound without the sonic boom. These aircraft tell a story of human ambition written in jet fuel and math. This is the X-planes, NASA's unsung aviation innovations. Fly High Hub. In 1947, the skies over California were hiding a secret. A small, orange, rocket-powered aircraft, shaped like a bullet, was about to do what no one thought possible. The Bell X-1, flown by Chuck Yeager, was built not for combat, but to answer one question. Can a plane fly faster than the speed of sound? On October 14, 1947, at 45,000 feet, Yeager lit the rocket engines, and the X-1 shot forward, shaking the air around it. The shockwaves built. And then a boom. The first sonic boom ever recorded by man. The Bell X-1 hit Mach 1.06, 700 miles per hour, faster than sound itself. That flight didn't just break a record, it broke a barrier that opened the door to supersonic jets, space travel, and the future of flight itself. In the 1960s, before humans ever went to the moon, there was a jet that almost did. The North American X-15 wasn't a normal plane. It was a rocket with wings, built to test the edge of Earth's atmosphere. Dropped from a B-52 at 45,000 feet, the X-15's rocket engine ignited, and in seconds it was climbing nearly straight up. Pilots like Neil Armstrong and Joe Engle rode this machine past Mach 6.7, over 4,500 miles per hour, touching the edge of space at 50 miles high. There was no autopilot, no computer, just steel, heat, and human nerve. The X-15 taught NASA how to control spacecraft re-entry, shaping what would become the Space Shuttle program years later. It wasn't built for glory, it was built for data. But in chasing that data, the X-15 became one of the most extraordinary aircraft ever flown. In the 1980s, engineers at NASA and Grumman decided to flip convention. Literally. The X-29 was built with forward-swept wings, meaning the tips pointed toward the nose instead of away. On paper, that design was a disaster. It made the plane aerodynamically unstable, the kind that should spiral out of control in seconds. But with a brand new fly-by-wire computer system, the X-29 didn't just stay airborne. It flew beautifully. At speeds over Mach 1.8, it tested how computers could constantly adjust control surfaces to keep a plane stable, something no human pilot could do alone. The lessons learned from the X-29 shaped the design of modern fighters, like the F-22 and F-35, proving that computers could tame chaos. It wasn't built for war or fame. It was built to show what happens when engineers stop asking, "Can we?" and start asking, "What if?" By the early 1990s, NASA and the US Air Force wanted to test something radical. What if a jet could turn without relying on its wings? Enter the X-31, a sleek experimental fighter built to master post-stall maneuvering using thrust vectoring. Instead of just pushing air over the wings, the X-31's engine could direct thrust itself, allowing it to twist, pivot, and even fly backward in mid-air. During test flights, it performed moves that looked like magic. Tight loops, instant stops, turns so sharp they'd rip most planes apart. The lessons from the X-31 laid the foundation for today's most advanced fighters, the F-22 Raptor and Su-35, both of which use thrust vectoring to outmaneuver anything in the sky. It wasn't built to win dogfights, but it taught us how to. Somewhere above Earth, a small windowless spacecraft silently circles the planet. It's called the X-37B, and it's one of the most mysterious aircraft ever built. Originally developed by NASA, later operated by the US Space Force, the X-37B looks like a miniature space shuttle, but without a crew. It launches on a rocket, orbits Earth for months, sometimes years, and lands on its own like a plane. What it does up there? That's classified. Some say it's testing new space materials and satellite systems. Others believe it's part of a military surveillance program. What we do know is this: it holds the record for the longest spaceflight by a reusable vehicle, over 900 days in orbit. Whether it's science or strategy, the X-37B proves one thing: the future of flight doesn't stop at the sky. Everyone knows the sonic boom, that thunderclap that shatters windows when jets break the sound barrier. But NASA wanted to change that. Enter the X-59 QSST, the experimental jet designed to fly faster than sound. Quietly. Built by Lockheed Martin for NASA's low-boom flight demonstration program, the X-59 stretches 99 feet long, with a razor-sharp nose nearly a third of its body length. Instead of a loud boom, it produces a soft thump, about as gentle as closing a car door. With a top speed of Mach 1.4, it's proving that supersonic travel over land could one day return without shaking cities below. The X-59 isn't just another test plane. It's a vision of a future where we can cross continents in half the time and barely make a sound doing it. Imagine a fighter jet, but there's no cockpit, no pilot, and no hesitation. That's the Northrop Grumman X-47B, a stealth drone built for the US Navy to do what no aircraft had done before: take off and land on an aircraft carrier, completely on its own. First tested in 2013, the X-47B used advanced AI and laser precision to perform carrier landings smoother than most human pilots. Its flying wing design gave it radar invisibility, and its range stretched over 2,000 miles, perfect for stealth missions deep into enemy territory. Though it never entered full production, the X-47B became a symbol of the future, where human skill meets autonomous precision. And it proved one thing: the next great pilots might not be human at all. In 2004, NASA launched something that looked more like a missile than a plane, the X-43A, an unmanned experimental jet built to break every speed record ever set. It was powered by a scramjet engine, meaning it didn't carry oxygen. It used the air rushing past at supersonic speed to burn fuel. The result? A blistering Mach 9.6, over 7,300 miles per hour. That's fast enough to cross from Los Angeles to New York in under 30 minutes. The X-43 didn't fly for long, just a few minutes, but in that short time, it proved that air-breathing hypersonic flight was possible. Its data helped design the next generation of hypersonic weapons and future spacecraft. The X-43 wasn't just fast, it was a glimpse of how far we could really go. Not all innovation is about speed. Sometimes it's about reinventing shape. Meet the X-48. Boeing and NASA's strange-looking test plane that blurred the line between wings and body. Called a blended wing body, the X-48 was designed to see if a single wide structure could make planes quieter, lighter, and far more fuel-efficient. The result was a futuristic design with no clear fuselage, just a smooth triangular form that handled like a dream. In tests between 2007 and 2013, the X-48 proved it could cut fuel burn by up to 30% and reduce noise dramatically. The design could one day shape the next generation of passenger jets or even stealth bombers. It may have looked like something out of a sci-fi movie, but it quietly showed the world that the future of flight might be flatter, smarter, and greener. In the 1990s, NASA dreamed big. A fully reusable spaceplane that could take off vertically, fly to orbit, and land like an aeroplane. That dream was the X-33, a half-scale prototype of the Lockheed Martin Venture Star. It promised no boosters, no disposable parts, and a flight cost of just a fraction of the space shuttle. The X-33 used aerospike engines, cutting-edge composite fuel tanks, and a sleek lifting body design that looked straight out of science fiction. But reality hit hard. The composite tanks cracked, the costs ballooned, and the program was eventually cancelled in 2001, before the X-33 ever reached the sky. Still, the X-33 wasn't a total loss. It pushed aerospace design forward and inspired engineers at SpaceX, Blue Origin, and beyond. Sometimes the most important missions are the ones that fail, because they teach us how to fly smarter next time. In the late 1960s, NASA asked a strange question. Could a spacecraft fly without wings? The answer came in the form of the X-24, a stubby, wingless craft that looked more like a UFO than an aeroplane. Built as part of NASA's Lifting Body program, the X-24 was designed to prove that a spacecraft could glide and land safely after re-entering from orbit. No parachutes, no ocean splashdowns. With its flat bottom and curved top, the body itself created lift. Pilots flew it up to Mach 1.6 and 71,000 feet, gathering data that would shape the space shuttle's re-entry and landing systems. It wasn't glamorous and it wasn't fast, but the X-24 changed everything we knew about spacecraft design. From that odd little shape came the wings of the shuttle and the dream of reusable spaceflight. The future of flight isn't just faster, it's smarter. Meet the X-62A Vista, a modified F-16 that can fly itself using artificial intelligence. Co-developed by the US Air Force Test Pilot School and Lockheed Martin's Skunk Works, the X-62 was built to train, not pilots, but algorithms. In 2023, it made history when its onboard AI dogfought a human pilot, and won. The aircraft can switch flight control systems mid-air, testing how machine learning can handle extreme combat maneuvers that would challenge even the best humans. The X-62 isn't a weapon. It's a window into tomorrow, where AI and human pilots might fly side by side. It's not science fiction anymore. It's real. And it's already rewriting the rules of air combat. In 2010, NASA and the US Air Force lit up the sky with a new kind of aircraft, the X-51A Wave Rider, a jet designed to ride its own shockwave. Unlike regular engines, the Wave Rider used a scramjet, a supersonic combustion ramjet, that compressed air at incredible speeds without moving parts. Once released from a B-52 bomber, it fired a rocket booster and then flew on pure air, hitting Mach 5, 5 times the speed of sound. At that speed, it could cross the United States in under an hour, or strike a target before radar even registered it. The X-51 wasn't just an experiment, it was a proof of concept for future hypersonic missiles and aircraft. It only flew for minutes at a time, but those minutes changed what fast really means. From breaking the sound barrier to flying on the edge of space, each X-plane was more than metal and engines. It was a question, a risk, and a step into the unknown. Some failed, some broke records, but every one of them changed what flight could be. The skies may seem conquered, but for NASA, the experiment never ends. You've been watching Fly High Hub, where we keep the story of flight alive.